So if you have opinions or thoughts or feelings about things you'd like to hear at this meetup, please scan the QR code. It will be up later as well. So this is the agenda for the evening. We'll have our fine speaker talking, and then after that we'll have our community marketplace, which is an opportunity for anyone to stand up and say, this is me, this is what I'm interested in. Maybe you're looking for a new role, or you're looking to hire people, or you're working on a project and looking for collaborators, or maybe you're just working on some tech and like, hey, I need some help from somebody just to bounce some questions. So we would like to acknowledge the Wurundjeri people, the traditional custodians of the land we're meeting today, and pay our respects to elders past and present. We extend this to all First Nations people here today. Our social contract, this is just a very simple thing, how we are all going to agree to behave this evening, and it's quite simple. Behave in a way that wouldn't embarrass your grandmother. Or to be more specific, we welcome a diversity of thought and experiences, and we conduct ourselves that reflects the best version of ourselves. So with that, I'm going to shut up and hand over to Abhishek, who is going to be talking through event streaming with GCP DataFlow. Let's give him a round of applause.
My laptop. Easy. Cool. Hello and welcome everyone. Thanks for being here this evening. So today we are going to talk about event streaming with GCP DataFlow. Before we get into the topic and talk about it, I would just like to introduce myself. I'm Abhishek. I'm a tech lead at Fabric. My expertise generally lies around designing and building real-time event-driven and ETL systems. I have good experience with GCP, AWS, and a lot of cloud-native infrastructure automation. So that's generally the area I are my core area and expertise on. Before I get into like the presentation, I also would like to talk about what Fabric is. So Fabric is basically it's a consulting firm where we specialize in strategy, design, and software engineering. We sort of combine all these practices to solve complex business problems for our clients. We sort of recommend right tool and technologies to our clients, sort of they can use in their business in either for the processes or software solutions or technology. As a company, we are sort of located in like different countries. So we have offices in Australia, Melbourne, and India, Philippines, China, Singapore. So we have 130 people sort of gathered across the globe. Yeah. So that's mostly about Fabric. Since like I've talked about like how we help clients and sort of let them solve these kind of problems. In my talk today, I'm actually talking about one of the problems which we sort of worked with for our clients. I will sort of give you a real example of what kind of problems we solve and like how do we solve it, how do we choose right set of technology, also give you some insights around data streaming and stuff. So before sort of I start, I just want I can't get introduction from everyone right now, but I just want to get a quick sense of or a quick show of hand from people. If you are from a data engineering background or if you are sort of a backend developer, please raise your hand so I can at least see and get a sense of people. Okay, there are quite a few. And have any of you worked with any of streaming solutions? Let's say not GCP DataFlow or anything, any streaming solutions? Okay, we have few people in the front. So what kind of streaming solutions if you have sort of used, if anybody wants to talk about that? Like any name of the streaming solution, if you have not used GCP DataFlow. Anyone, any names? Okay, cool. All right, that's good. Has anyone used GCP or like people familiar with GCP? Cool. Okay. Cool. So I think I'll get started. I'll actually start with the agenda of this thing as well. We'll start with like some of the basics of event streaming, like why event streaming, right? And some of the basics around it. Then we'll talk about some of the use cases. The use case is basically like the real client problem which we have solved as Fabric. And then we'll talk about some of the streaming solutions and GCP DataFlow. We'll also do a quick comparison of traditional versus the DataFlow based solution, because it sort of highlights and sort of contrasts like how we have improved the system from the old world where we have used traditional technologies to solve the same problem, versus using something like GCP DataFlow, which has a modern tech stack built, and that sort of solves the problem. And then we'll actually about learning and some of the key wins which we sort of got out of the project, and some of the learnings of using streaming solution like this, right? And then after that we'll have a small QA sessions and stuff. Cool. Okay. So let's get started with why event streaming. So I'll probably start with like just talking about simple things like online shopping, right? So when you order something as an online shopping on, let's say you're buying a shoe, right? That's just like a simple process for you, but then you also have a lot more things attached to it. And from customer point of view, you are always interested in knowing about where is your order, right? That's basically the crux of it, like as from customer point of view. Now, if you think about from a logistics perspective, a company which actually is targeting the logistics of the whole solution, which is like thinking about warehouse, packaging, shipping, how something gets ready, right, and until the delivery, they actually have to manage a lot of these events which sort of come into the system, which is event coming from different and various sources, right? And somehow their central system needs to sort of synthesize all of them, build something meaningful, and provide you to as a customer. So that's basically the kind of thing we are generally like very common in nature in logistics domain or any other domain in general, where you have a lot of data coming in from various different sources. So I'll sort of move ahead from this and just talk about some of the observation from the current thing which we have seen. So the current architecture in here, what it looks like is that business relies on a centralized system for event processing and notification. So they have like one system which gets all the events in, it sort of synthesizes everything and then sends notification over there. The second thing I would like to highlight is also scale of it, which is basically if you imagine a company which is like, let's say a countrywide company which has actually delivers in almost all parts of Australia, they might have something the scale of like almost a countrywide scale, right? And for that they might have to deal with like thousands of parcels and they need to process throughout their network daily. The data volume might be higher than that because one parcel deals with not just one event or two event, it might generate like a lot of events. So you might end up with millions of events throughout the life cycle, right? So that's the key thing which I want to sort of highlight around the scale of it, because where data streaming solutions sign up is when you actually achieve a scale, right? You are solving a problem with a scale. So just to sort of summarize the whole thing, which is basically what is the current need here is the scalable fault tolerant solution which can consolidate all these event streams coming from these various sources, right, and provide some insightful notifications to their customer in real time. So that's the business opportunity here, which is basically building that system which sort of caters for this use case. I'll probably head and talk about, I've used a lot of other words like event streams and stuff like that. So let's go into what is an event stream, right? We'll define event streams and then we'll talk about how do we process those. So let's start with some of the event streaming basics. So starting with what is event streaming, and before I want to get into that, I'll just define like what an event is. So just a simple definition, an event is a record of something that has happened at the system at specific point in time. Key facts about it, it's basically immutable, you can't change it, once it's generated, it's there, it's a fact, it has some information, right, and it's timestamped and sort of also watermark is another word for using timestamping there. Watermark is like also something useful for other things, like when you are doing a processing of it, you can gain various other insights, which is like how far event time has progressed, right, and how far your processing is from your data generation, and that's where watermark becomes sort of essential, a component to determine what is valuable and what is not valuable. Like a data might be relevant only in context of time. I don't want a notification to be received after my package has delivered, right? That's not the use case. So that's why the timing always matters around these kind of systems. Now let's talk about the stream part of it, which is the streaming part of it. So what a stream is a continuous unbounded sequence of events generated over time. What do we mean by when it is continuous, which means it's always flowing, you always have something out of it. Then you also have unbounded sequence, which means it is like it's basically not ending, right? You have like almost getting there is no defined end to it. Then you also have like ordered sequence, like it always progresses over time, right? You get an event for this time, and then you get n+1, n+2, n+3, right? It's always there. So now combining those two, just giving a quick definition around what an event streaming is. It's a real-time continuous capture and processing of data as it's generated from sources. So that's basically what event streaming is. You capture the data in real time and process that in near real time and provide and do whatever your business need is. Yeah. Some of the key considerations, which is basically while we're dealing with event streams, is that since event streams are unending data sequence, right, there are a lot of other constraints which sort of come there, and we probably need to be mindful of that. And then what do we mean by constraint is also like it's not finite, it's incoming always. So what you need to understand is like how do you handle data, which is one of the thing is like how do you partition the data, or how do you say, okay, where is the defined net? Because let's say if I have to calculate an average of something, if I have to calculate a sum of something, I need to break that down into something meaningful of a window or something. So that's basically where the concept of windowing becomes an important thing, where you define and sort of say, this is like the definition, this is the start, this is the end, I'm only interested in that and want to do that. The other key aspect of that is also partitioning. So sometime you may want to partition your data because of various reasons. We'll talk about those later on. But it's a very useful concept to partition data based on some kind of a key to get different kind of insight. The second part of that is once you have actually sort of changed your like data into something where you can manage it in a small form, you also want to sort of aggregate and do some kind of transformation. This is your core business logic, right? What you want out of it. You want to do aggregation, you want to do group by, you want to do sum, you want to do like median, whatever. That is basically the core business logic. And you can use various tools or write your custom code to do that. The third aspect of that is also the streaming engine. And now why this becomes important, I talked about scale in the initial time, right? Scale is definitely a very important factor when you are doing streaming engines, when you are doing sort of like event streaming. And what streaming engine provides you is it provides you some kind of fault tolerance on the system, which is, let's say if something fails, I know like how to recover from it and what is the backup and stuff like that. Now this is a very solved problem, like it's not something new. So now I think generally what we do is we delegate these problems to streaming engines. They take care about all these things related to how fault tolerance will be managed. So let's say if I have 4 nodes of like which are doing some kind of processing and one sort of dies, it's the responsibility of the streaming engine to figure out how to recover from that, right? That's the responsibility we have given. And that's how we also achieve scale, which is basically like using the parameter which is like your input parameter around backup and sort of backlog what you have developed, using that to scale yourself. So that's basically generally the responsibility of stream. Now I think these are sort of a little bit advanced, which is mostly around state management. So let's say if you are doing processing and if you want to accumulate some information in memory for some reason, and we'll see an example of that today, how do you deal with that? And then the last one is about timers, which is basically how do you handle time, which is basically how do you say that I want to limit and define that this is the duration I want my job to be done, and after that I don't care about it. So you need some kind of a timer to warn you and give you control back to say something about it. So that's like the another consideration or the last consideration we'll talk about today. Okay. And if you have any questions also, you can feel free to raise your hand and talk. That's all right. Cool. All right. So let's move to the first consideration, which is basically around windowing and partitioning. So I'll talk about windowing. So windowing is like, as the name suggests, you basically have, let's say you have data stream coming in from somewhere, right? You're trying to divide that frame into that data stream into some small frames based on your requirement around, okay, I want a 5-minute chunk or a 10-minute chunk or whatever, and you basically divide your data to actually do any kind of aggregation later on. So this is just handling part, which is like, how do you handle the stream? And there are multiple ways, and I've listed few of them, which is like you define a fixed window, or you can do a sliding window, which is a different technique around that, and you can do a session window. So let's start with the fixed window thing, which is very simple, where you divide your data stream into small finite chunks, which is basically, let's say I'm saying 5 minutes or 5 seconds. You just divide your data into 5 seconds, all of them. So let's say if I have a data coming in from this stream, I have divided my data into like 5. So if I have to do an operation, I will do operation in this window. So that becomes like, you have a key for that and you have a window for that, and you will do the operation in that window. What kind of questions, basically sort of what kind of use cases are there for this? Like for example, in the logistics domain, how many parcels are delivered every 5 minutes? Let's say if I want to just get the same simple answer, and this is where it shines. You always get information around how many parcels are delivered 5 minutes. Like this is the simplest way to do it. The second is basically sliding window. It's very similar to the fixed window, but one of the things what it does, it solves a problem, or sort of it sort of informs you in a different way. It, instead of giving you an exact figure, it also gives you a trend over it. And why do you want that? So let's say, for example, you have a spike in one of the windows, which is, let's say you got 10 orders in one, 0 in the next one. You'll always have like this jump over there. So it's not giving you a trend over time, it's giving you like finite numbers. And let's say you are not interested in finite numbers, you are interested in trend, because that's generally what matters, like how over time you're progressing. You probably put that in a sliding window format, and that's where the sliding window sort of comes in there, right? So for example, here, if you see here, what my window size is 10, but then it's also updated every 5 minutes, which means it also captures, like in the second window, if you see, it also captures the 5 minutes of before, like the previous window. So that's basically the sliding window. The third is the session window, and this is like sort of very intuitive to understand as well, which is like you're trying to divide your event stream into some kind of windows based on an activity, which is where you are saying that I want to capture, let's say, a question around how many parcels are processed by a warehouse worker in one sitting. So which means you are capturing the session of that user, and this could be like any other different use cases. You are trying to capture the session of the user and get an sort of insight on that. This is where it becomes useful. And it can be also done in other scenarios. Let's say if I'm doing online shopping, I can put this behavior on someone else, where I can say, I want the constant feed until this user becomes inactive. So I can group all this, what they did in one session, right? Like how long their session was. Did they browse products on the website, or were they trying to do like search something else? Like we can get this kind of insights. So that's windowing in a nutshell, right? Any questions on this? Or okay, cool. I'll probably move to the another part, which is aggregation. Again, a very simple concept, which is you're trying to do your business logic, which is basically, now if you have a window, which means you have defined how sort of your data is defined in a small set. Now you are trying to aggregate the result on top of the window. So let's say this is my example here. My window sort of captured this thing, which is basically for parcel 1 to 3, the status is it's created. For parcel 1 to 3, it's picked up from somewhere, and then for parcel 1 to 1, it's created. Now this is my sort of, I have captured this information. Now I want to aggregate this information. So how do I aggregate this information? One of the simplest is group by key, and that's one of the basic operation. I think a lot of people, if you are from data engineering background, group by key is one of the famous operations here. You want to define a key, group all the elements in that key, and that's what like simple aggregation is. Like it could be complex, but this is like the simplest example we can think of. Cool. All right, let's move to some of the event streaming use case which I was talking about, because so far I have just talked about the theory of like what event streaming is and like how does it look like, but we will talk about a real like a real world use case, and this is something which we solved for one of our clients, and then we sort of were engaged with them from the discovery process to like also deciding the tech stack and stuff like that, and also making sure that it is in production, live, running smoothly with whatever scale we have, right? So what the use case is, I'll talk about it. It's basically a logistics company. That's the background. They wanted to develop a fault-tolerant event streaming solution, and this solution needed to leverage some of the event streams from their parcel facility. So imagine like a big company which has like a parcel facility which has a lot of parcels coming in and going out every day. They wanted to basically consolidate all those events, right, which are generated in that parcel facility, and generate some meaningful customer notifications and other events to support their business functions. So customer notifications is, oh, your parcel is at X location, right, or your parcel is moving to another location, or it is delayed, these kind of notifications. Our other business function could be like, oh, the postage was wrong on this, or they didn't pay the price properly, things like that. So these kind of other business functions are also sort of use case for this. So this is like the problem statement. I'll go into and talk about what parcel facility look like and what the scale we are talking about. So parcel facility is basically a warehouse where parcel come from and they sort of get sorted where they can go to their next destination. That's basically like simple job of parcel facilities. Parcel come in, they get sorted, they get into a different kind of chute or a truck or a bag, they get routed to their next destination. That's basically what parcel facility is. And as you can see in the picture, it has this large big mammoth machines. They look like very similar to how you see things in airport, a conveyor belt where parcels are sitting on top of it and then it's moving forward, right? And during this process what happens is they get scanned, right? They get weighed, they get separated into different chutes. So basically it gets divided into multiple, it gets forked into multiple other frames, and at the end they get sort of packed into some small container or box, and then they go in a different truck for their next mile delivery, right? Because it might need to travel to next parcel facility and stuff like that. So that's the process. And all of them have all these machines have multiple sensors, and these sensors collect multiple kind of information. For example, like information could be about how much that parcel is, what's the weight of the parcel, right? What's the barcode on the parcel, all right? Or if I want to take a picture of the parcel, there could be many other scenarios around what kind of data you can capture. So like let's imagine like there are 8 to 10 different kind of sensors, and depending on the machine, it sort of captures this information and gets it. And these are like relevant information for making business decisions, which means they need to be consolidated somehow. So, and the scale of this is like in a general, like a machine can sort up to 30,000 parcels an hour. Like that's like generally the scale of it. And their business has like hundreds of these machines across Australia. Like they have like almost hundreds of machines split across like Australia, and they're getting sort of sourced into one place, right? So this is basically parcel facility in a nutshell. I talked about some of those events. So we'll be working with those events, and I'm giving example of 4 such events, which we are going to think and talk about. So the first event is an induct event. What is an induct event is basically, let's imagine a parcel getting into the facility, and it's basically placed on the belt, right? That's basically you're doing an induction of the parcel, which means you are capturing, that's the first event you're capturing. The second event of that is you're probably, and now I think the order sort of might not matter as well, but then generally this is the sequence. You capture a barcode of the parcel, which means you read the information on the parcel, which might have information about where this is coming from, where this is going. All this information can be correlated in the system. The third event likely is a weight event, which is basically where you're doing a weigh of the parcel, you're weighing the parcel and saying, oh, this might be like 500 grams or like whatever dimensions and size. And it's not just weighing, I think it also captures size as well. Let's say if it is how many centimeters long and so on, all those stuff, right? And then last is basically an output event, which is basically you've sorted the parcel, you've got all this information, now you want to put that parcel on a correct chute, which is basically targeting it to the right conveyor belt based on this location where it is going next. And that produces an output event, making sure that this is like a successfully sort of a parcel which has successfully sort of passed all the sensors and created one. So think of this as like the first event which sort of generates. Think of this as the final event which gets generated. And between that, I have just taken an example of two, but like there could be many others. Like for example, there could be OCRs, there could be images, there could be other kind of sensors. But this is the example we will stick with. So what we are going to do with this is these events are generated individually, separate, right? They are not coming from like in one form. What we want is basically in order to provide any sort of useful notification to anyone, we want basically to combine all these events into one event, and we'll call it sort event, which will have detail about when it was inducted, what is the barcode of it, what's the weight of it, when it was actually sent to a different chute, which means you combine all of them into one, and then that becomes your sort of event for sending it to notification to customers or sending it to a business function to do any other things. So that's basically the problem statement. I'll also highlight some of the business rules. So some of the business rules are around this is you want to consolidate all these events which I talked about into a single event. Given is the stream of events can arrive in any order, like there is a delay from the source, right? You always do not receive the event in the same time as you were sort of expecting, and it was getting generated. By the time it reaches to the processing center, you might have like change in time and stuff like that. So they might arrive in a different time. And sometimes what happens is the sensors are not also placed like almost, they're placed like far away and stuff like that. It takes time. And that this also can sort of implicate that they can take from few seconds to up to 30 minutes as well. So few seconds is generally like for most of them, but then there are times where you might have certain delay with an event coming in. For example, output event, let's say it required manual intervention of someone. So let's say the machine is automatically doing sorting and suddenly it can't determine where this parcel might need to go. So what it might put that in a different conveyor belt. Somebody will come in and see, oh, this is where it is going. They might need to take that up, put that on the right place, and then basically from there they will sort of it will continue. And that might take up to like 30 minutes. That's generally the SLA, right? And needless to say that some of these events may be lost due to another, like machine might have choked or something where you might not get these events on there. And then some of the events might not be relevant as well. Like imagine if you are sending a parcel, it might come with different barcodes. Let's say you bought something from Kmart and you just put a label on it and you're trying to send something. It might have like 10 different barcodes on it. So you might have some barcodes which are not relevant, or you might be returning a parcel, it might already have something on it. So that is not relevant as well. So you need to basically be mindful of some events are relevant, some are not. It means I need to, in my business logic, I need to drop something as well. Latency is also around, we need to process all these events within the 3 seconds of event availability, the moment you get in. within 3 seconds, make sure that customer is notified, business is notified around that this has moved, we are okay. So in a nutshell, what happens is like parcel is considered complete when all these events are received or the timer expires, and that or is basically the 30-minute which I talked about, right? So that's basically the problem we are going to solve, which is basically we are using sort of some of the streaming engine's capability to consolidate all these events and create a notification out of that at the end. And given that the time sort of, we are also putting this timer around it, which is the 30-minute timer, and then saying, oh, this is a useless event, we want to discard that. Cool. So before I jump into the actual problem statement, I also want to introduce some of the streaming solution options and also GCP DataFlow, which we chose for this particular problem. So there are like a lot of streaming solution options there, and it's really hard to choose which one is better from what. And I think that sort of, and I'm sort of, we picked GCP DataFlow, but it might not be relevant for your project because of certain reasons, right? So it always is helpful to determine what those reasons are and then sort of use it. So what I have done is I put a criteria around what things were needed on the project, right? And then we did a small comparison around what kind of streaming solutions we want to use. And remember, we talked about streaming engine in the beginning. This is basically the streaming engine we are choosing from. We are not just choosing just the API, but also the streaming engine behind it. And like Kafka Stream, like Streams is not the engine, Kafka is. So I have put it there just to, they might not be one-to-one, but they generally are associated with some kind of an ecosystem which can be considered for this particular use case to solve this problem. So we'll talk about GCP DataFlow in detail, but I will talk about the criteria first. One of the criteria was we wanted to, basically we had millions of events, like imagine millions of events coming in an hour. You want some kind of high throughput around that. So one is, the second was low latency. We wanted processing to take like less than 3 seconds. The other need was also stateful processing and timers. So I did talk about stateful processing and timers in the aggregation, but I have not talked about in the context of what you call GCP DataFlow, which we will see that how we are going to use stateful processing and timers to solve this problem. Then we also wanted something where minimal operational overhead, which is like I don't want to maintain a lot of these things, which is like I don't want to scale my cluster. I don't want to sort of upgrade my cluster, do maintenance on it, patch work and stuff like that. Those is something which we wanted system to manage, and that's why we sort of chose managed service was one of the sort of choice for this one. I think this is actually the native integration thing, which is we wanted something in the GCP ecosystem. It was not like a must, but it was something which was like really recommended because a lot of this data was available in their GCP ecosystem, and a lot of other systems, I'm talking about the notification system and stuff, they actually were in GCP ecosystem. Now, if you have something already tied in there, it's sort of easy to integrate, like you can do native integration with, let's say, PubSub, which is the publisher and subscriber service from GCP. You can sort of use some of the databases and stuff like that, and all those alerting and monitoring comes for free as well because you already have a standard practice established around the same ecosystem, right? The other was then simple development and runner portability. I think this is also, I think, not like a hard requirement or a criteria, but I think it was one of the nice thing to have, which is we wanted something simple where, let's say if tomorrow we want to change that to a different streaming engine, we should be having that capability. And I think it was not like a really hard requirement, which is something nice to have. And then also something, it also makes your code easy to test, right? Why I would say that is because let's say if you have something portable, you can deploy that on, like in order to test that, you don't need always GCP DataFlow to deploy on, right? You can deploy on something local, like you want something, a smaller version of it, and you can deploy there. So that's basically like one of the nice to have things which we had. Now, if you look at the sort of chart or the table I have presented here, I think GCP DataFlow, like or the Google DataFlow was like one of the sort of obvious choice for us because one of the things is GCP integration was there, but then it also has a full streaming support. it was a managed service, and it also had the programming model which is Apache Beam, right? And Apache Beam is, so I'll talk about Apache Beam as well. Apache Beam was like, it's a programming model, right, which lets you create your data pipelines, either ETL, which is basically your batch processing, or streaming, in simple abstracted form, which you can deploy to multiple engines. So let's say if I wrote my code in Apache Beam, I can go ahead and deploy on DataFlow. I can go ahead and deploy on Apache Spark cluster. I can go ahead and deploy on Flink, which means like these are the options I have available. And it also has something called direct runner, which means you can spin it up locally and you can actually test and deploy on that. So that's what one of the, I think, selling point also was there with Apache Beam. And I think the other consideration was also Spark. So how does Spark works is like it's actually built for sort of, I've used Spark like probably like almost 10 years ago. It's like very old. But Spark is basically really good for batch processing as such. And how does that it support streaming is it does creates micro batches in order to support the streaming in a way. So it sort of, you get the result out of it. It just is a little inefficient in that way. There's another ops overhead around maintenance of it, which means like deploying the cluster and stuff like that. You have managed service available of Spark. It's very old. Databricks is one of the companies which actually have Spark clusters, and you also have Amazon EMR as a service available in AWS if you are. It also, the programming model is Spark, so everything is natively written in Spark. Flink was another sort of strong one, which is the open source Apache engine again. One of the problem with Flink was you have an ops overhead because you need to deploy that somewhere. It has costs associated with it. You have to maintain the cluster and stuff. But otherwise, Flink is a very good contender for this one. Like if somebody had a Flink cluster already, and if you are using Confluent is one of the offering where they offer Flink as a service. So if you are using that, it's a great choice. Amazon Kinesis, again, this is quite good, but again, it does sort of differ like in terms of what kind of things it offers. And it's very good in terms of if you are doing things in AWS for sure, but otherwise we sort of didn't consider that. And the Kafka stream is again like it's a really powerful library which sort of provides you way to process your data in streaming fashion. But one of the thing is you also have to have clusters and stuff like that. So that's why we sort of didn't go ahead with this one. So this is for our use case, the minimizing. One of the thing was like minimizing the operational complexity was very important, and we also wanted to support stateful and sort of low latency processing with this primary driver, right? So I'll sort of just briefly talk about GCP DataFlow. Again, I think I've already sort of highlighted most of the things around GCP DataFlow. One, it processes large volumes of data reliably and very efficiently, right? It has a good native integration with other GCP products. It's not just because of the ecosystem, but it also has something called connectors, which can connect with, let's say, your existing PubSub systems, and that's what we sort of utilized, where we didn't have to care about how we want to connect to GCP DataFlow to PubSub, because it has a connector built in already, which you can just utilize and sort of use it. It has connector for other things like BigQuery and GCS, like all those. It automatically scales based on your workload. So if, let's say, if I put PubSub in front of it, there are 1,000 messages in PubSub. It's basically processing in one node. The messages become 2,000. It automatically will spin up another node, auto scales. Same again, it will go back whenever the load is down. It has a built fault tolerance and automatic recovery. It's built on Apache Beam programming model, as I talked about, and it supports the stateful processing and event time semantics. So that's the key thing about it. We'll talk about Apache Beam programming model. How does it look like? And we will go in the code. I hope everyone can see the code from the back as well. Cool. All right. So how does Apache Beam programming model works like? Is basically it has some basic concepts around something called pipeline. So you always create something called a pipeline where you define your stages in terms of processing. So let's say you start with saying, oh, this is my pipeline where I am sort of I will have multiple transformations. You create a pipeline, you read the stream from either a batch, which is right now here it's p.apply creating event from just a list. You can get it from a streaming platform, which is, let's say I want to get it from pub/sub collector. I can write the code for that, and probably it will automatically connect and it will get the stream rolling from there. But you can do batch as well, as you are seeing here. If you're reading it from a file, it will be batched. Then you do your transformation. So that's the third concept. So pipeline, P collection, the third transformation is Pardue functions. So what is a Pardue function? That's basically your transformation functions. This is where you define your core business logic around what do you want to do with it. And that's the third element, and that's the one of the important elements where you are going to write code if you are a developer or if you are a sort of the data engineer who are writing your processing, because other things are sort of managed, but this is the place where you have to think about how I am like optimizing things or not, and this is the place we'll be writing. So we'll talk about Pardue functions more as well. So here the example of Pardue function is taking a do function, and this is, by the way, in Java. You can also write in Python and other languages. Apache Beam does support in Python as well. Some people generally like Python as well. Okay, coming back. So here we are just doing a transformation with like taking the input and making it uppercase. And that's about it. So this is how the Apache Beam code looks like, right? It's very easy to write. You can write your transformation in terms of pipeline, and then sort of just run it. Cool. Any questions so far? Because I did talk about a lot of things. Okay, cool. And you will have a QA at the end of it as well. Okay, so this is one of the main concept generally I want to touch base upon, is something called stateful processing, and I've been talking about stateful processing for a long time. Stateful processing. So what a stateful processing means is you need to so let's say if you are actually doing some operation, you want your pipeline to remember something from a past event which has happened so far. You define something called a state, which is basically, let's say it could be like a list, it could be a hash map, it could be something. So here the state is defined in the Pardue function. The state is defined in this, where I put an annotation state ID events, and then defined a variable called event spec, which is basically a state spec, which is of a backstate of a string. So which is basically defined a place where you can store something in it, and then later on when you're processing the event, you can read from that state to do anything else if you want. So that's basically like the concept around the processing or the sort of state processing, right? You can store certain things, and then you can get it from there while you are doing the transformation. So that's what the state sort of provides you. It also provides you, one of the thing is, it provides you sort of the isolation, which is basically, it's basically based on the key. So always when you are creating a state, it is always based on a key, and you generally partition your data based on some key, so that a state is created for that particular key. It's not that a global state, it's a key for that particular key. So let's say if I have an event for a parcel, and I have created a key for that parcel, the state is created for that particular parcel ID, which means that it will only have the information about that parcel, and this you automatically have a grouping by default. And this is one of the examples I used in the early slides, where I had like list of events which is like parcel created, parcel picked up, and stuff like that. You're just doing a group by key in there. So that's basically like the isolation it sort of provides. And the state storage is sort of backed by DataFlow or the runner which you have, and the recovery is also sort of backed by the runner, which means if something fails, it knows where it last started processing on, it sort of can pick it up from there. So that's the stateful processing. Like, I hope that's sort of clear, right? Cool. I think the third concept, and I think this is the last concept about the programming, and then we'll jump into using these concepts in the solving the problem. And I have an animation to sort of show you how does that get solved as well. So this is the last concept of which is called timers. So what does a timer do? A timer is again like a Java concept in Apache Beam, which lets you create a timer, a simple timer with given any time around. Okay, I want timer for like maybe 30 minutes, 5 minutes, 10 minutes, and when I want, when my timer expires, tell me when it expires. I want to do something about it. And this now, if you have been following up me with the problem, which is why I mentioned 30 minutes of sort of the 30 minutes number, right? I want to know within 30 minutes what happened. Now, if after 30 minutes I get to know I sort of there is nothing coming, I want to do something about it. I don't want to hold that thing in the memory for a long time. So I want to do certain things about it, and that's where timer sort of becomes very helpful, where I can take and call back action on that. So you define timer like this, it gives you a nice little annotation where you can, on expiry, it will get called. So that's about it. Yeah, so I think after this we'll probably look into the solutions which we had prior to this, and then we'll compare with the DataFlow solution which we have put together. So this was the traditional solution which we had before, how things were sort of managed. So the traditional solution had like an inbound queue which was sort of getting events from the sorting facility. So sorting facility is where it starts. The inbound queue would get all this information, and then it will basically go to like a bunch of other nodes which are processing for the similar queue, and what they are doing is they are just writing the data into the database. So you have an Oracle database, and again this system was written like 15-20 years back, so it's like Oracle was the choice for this, and we write the whole data or the events which are coming into database. What happens is that after that, an outbound worker, which is like sort of highlighted here in the yellow at the side, what it does, it reads all the events from the database of the same key which are related, and then basically what it does, it creates a sort event which I talked about, and then it sends to the notification system, which means you are like your workers are writing data into the database, and you are basically doing the consolidation on a single outbound worker. Now, like the thing is, what is very apparent here, where aggregation happens here, which is a single worker, you can't put multiple workers again because your aggregation will not work, because you can't operate on the same data from two different threads and stuff. So here, one of the limitation was the scalability was because one is the single worker, and then also you have a DB there. So that's why it was very hard to sort of scale. Like it can consume a lot of events and it can store it, but it will increase the latency later on because this worker will probably take time to process all these events. So that's the old solution which we had. Any questions or any, is it clear or, all right. We'll move to the next solution which we sort of put in with DataFlow. So if you see, it's very similar. There's not much of a change. Data is coming from sorting facility into a GCP PubSub topic. Again, short intro, GCP PubSub is basically like a what you call a queue-based service in GCP as a native queue-based service where you publish you can publish a lot of events to the queue, and you can have multiple subscribers reading from that queue, and you will probably get the same idea, right? It's basically a queue. So what we had was we sort of made DataFlow subscribe to this queue, and then DataFlow had started, like we wrote all the code which is basically the aggregation logic around this whole thing in DataFlow itself, which means nothing is getting written to the DB, everything is getting consolidated in memory while like the events are getting generated. So you consume the event, you process the event in there, and as soon as you have the event, you sort of push that to your outside sort of notification system. So it's out of the game. We did had to sort of consider, like you see here, a Redis system here. So probably we didn't eliminate the database completely, but it's serving a very different purpose. What it does, it stores some of the incomplete events, and I think the reason why we kept that is because your DataFlow lifecycle also is sort of built around the state, right? And then there are situations where you want to have a persistent state as well, and like generally it won't matter if you have your business rules set to 30 minutes, and after 30 minutes if the events are not necessary, then you probably do not need this kind of a Redis database at all. But let's say if you want to do some kind of audit, something like you want to do replayability or some sort, you probably need some kind of a store. So we put a small Redis database. You put something, let's say an expiry key on the key saying, I want this data to expire after 7 days. The data almost is gone. Like you put a TTL on it, and the data is almost gone. So that sort of solves the problem differently. Now I'll talk about how the processing looks like inside DataFlow, and this is a pipeline view. So remember we talked about pipeline. Pipeline will have your input, which is like you are starting where you are reading it from some source, you are doing some Pardue functions, and then you are sort of writing it back to the output. So how our pipeline looked like was read pub/sub messages. As soon as an event is made available to the node, it sort of is read, it's basically available. You partition by key, partial ID becomes your key, and the event, all the events related to that, which is basically, let's say you have your induct event, barcode event, another, those becomes like your child and list of those childs. Then you basically accumulate all these parcel events, which means what happens is each parcel event, what we do is we create a state for that. Let's call it a bag state. It's a bag state. It's like imagine a bag where we are putting an event there and attaching a timer to it. It's like you have a bag, you put a timer on that 30 minutes. If something never happens, give me a call back, right? If an event comes, I am going to visit that bag. But if a sort of event is sort of not coming, and after 30 minutes, what happens is like I go to that bag and see, oh, nobody is coming here, I need to clean it up. So then in that situation, I write to the database. But if something is sort of successful, which means I have got all those things within the time frame I have defined, I will publish my outbound message to the system, right, to the downstream system. So that's basically how the data flow event or the pipeline view looked like in our case. What we'll do is we'll do a small simulation of event sequence to sort of help you visualize this, how does this work. And for this example, what I have taken is I have taken like this list of simple events, which is basically you have parcel 1, which has an induct event, barcode event, and a wait event. There are 3 events. And for parcel 2, an induct and a barcode event. And then after that, parcel 1 produces an output event, and parcel 2 produces a wait and output event at the last, right? So this is the event sequence, how these events are flowing in, and we'll see simulation of how does that behave inside the data flow memory. So if you see on the table here, so there is a table on the side, the table has things in yellow, that is what the current event sequence is. You're tracing the code here, right? Let's say the first event came, which has induct, barcode, wait. What does DataFlow do? It created a bag. Now you see there is a bag inside it. There's a timer icon attached to it, which is the 30-minute timer on it. We put that whole thing in that all the events in that bag, put that in the timer, and sort of keep that in the memory. What happens in the next step? Parcel 2 event comes in. You got an induct event and a barcode event. Nothing. You just create another bag, put the induct and barcode again, put a timer on it, done. Cool. This is the interesting one, which is parcel 1 output event comes in. Now, after these 3 events, after this 4 events, that's what we defined our sort event like. We sort of, now we say that the parcel is sort of complete. We have all the information related to the parcel and we are done, right? We want to send notification to the customer, hey, this is sort of processed at this facility. Everything is passed from this facility. What DataFlow will do here and what our code probably will do here, it takes the thing in, publishes to the outbound, deletes the bag is gone. And let's say wait event and output event came for the bag 2, again same thing happens, it's gone. Now in the case, let's say if the event didn't come in, I don't have animation for that, but if let's say the event didn't come in, what will happen is your bag will basically get expired. You will get a callback on a function where for that same bag, which is basically, okay, probably clear this up from memory. right? You should not keep that in memory. And that at that sequence, what will happen is it will be written down to Redis for deletion later on, right? And then let's say if you want to basically accumulate that same thing back again, let's say tomorrow business decides to say, I want to sort of read that back from there and sort of do that, that's also possible. So that's like the simulation of the event sequence around this one. I hope that was helpful. Okay, cool. So what I think I have basically talked about the problem and whole things around this, and also I'll sort of want to give some learnings which we had during this project and on some of the key wins which we had for the customer. So one of the thing is basically performance test, which is very, very important for system scales like this, because we had a system where we wanted to sort of have good performance in terms of peak loads. Let's say Christmas time or Black Friday time, there are a lot of parcels and stuff like, so we want to test on the highest peak load which you can expect. Do that first. Even before writing our whole consolidation problem, we tested before that, just to make sure that this can handle the scale, and then we sort of started developing the logic, and we tested after that as well, but it's just to understand that. The other part is also around finding out like right configuration and balance. So for example, DataFlow gives you certain options around choosing which machine you want. You want to compute optimize, memory optimize, and stuff like that. Let's say if you're using states, you are using timer, you are using something that requires CPU, memory, you can play around with those stuffs. And that sort of gives you an edge in terms of how you want to sort of solve this problem, right? Then I think the second part is around handling the deployment for a streaming service. And this is very important because streaming solutions are real time, that event is coming in. How do you deploy your code without affecting it? And that becomes a key challenge, and you need to figure that out before you do anything else, because you can't stop the pipeline. If you stop the pipeline, there will be a lot of backlogs, and then there will be disruptions. You might need to do that in some cases, but in a normal deployment should not need like stopping the pipeline altogether or stopping the event sequence together. You should be able to roll it out. And then how did we sort of define this, and how our deployment pattern was that, let's say if I'm creating a new service, what happens is a new DataFlow service is deployed, like it starts accepting the connections immediately on that. The older one starts draining connections. It will keep processing until the 30 minutes is there. Until the timer is running, it will keep running those there. It will start migrating few things here and there, and then it will sort of delete the whole thing. There are certain situations where you might not be able to migrate. The reason for that is, let's say, maybe mismatch of Apache Beam version and stuff like that. We even tested for that, and that's why your deployment pipeline needs to be very sort of solid in terms of handling this mismatches. One of the specific version thing is, let's say if you're doing version upgrades, and that is the situation where you might end up into a situation where you have to drain the pipeline. Again, what we built is, before doing version upgrades blindly, you actually do state change or check where DataFlow actually tells you, right, that you cannot upgrade the cluster and you have to do certain other steps. We define those things in our pipeline where it can be done automatically as well, which means I will drain the state and then start the traffic afterwards. So that is also something you need to handle. The third is basically building replayability in the solution, which is very crucial for an event-based service. It's not just creating so one is you create your dead letter queues, which are absolutely essential for your service. If you fail to process something, you definitely need to put that in DL queue. But then you also need to build a solution to replay things so that you can recover from that state. Let's say for any reason, XYZ reason, your service was down, something was problematic, you don't lose the event. And that's why we invested our time in building something where a simple pipeline which can just replay the old messages. That's it. That's the simplest you can do. You can build a lot of other things, cool things on top of it. Let's say you want to reprocess, change, and stuff like that, but replayability is a must. The another part is, I think, and this is very specific to the project, but I think it's also a common learning, which is simplify the complex logic if you have a configuration. And this is where this became sort of very important for us, which is we had different kind of sorting machines, right, which had very different requirement around aggregation. I showed you 4 events. It might have 8 or 9. Out of those events, some of those might be relevant for certain machines or not. And that kind of logic complicated a little bit. And what we did was we extracted those things out into a configuration instead of doing the whole thing in the code. Now, let's say tomorrow I get a new machine, like the organization decides to get a new machine which has a very different requirement for what kind of events it wants, what kind of configuration it wants. You basically change the configuration on your pipeline. You don't need to check the code. You don't need to change the code, right? The last and the not the least one, which is like defining robust observability metrics for your business, which is like what is important for you, which is your DLQ metrics around what's the state of it, your latency metrics. If your pipeline is lagging behind, you probably need to sort of raise like P1, P2 alerts around those. Service status, which is, let's say, if your streaming service is red, failing, or the lag is there, you probably need to define alerts for those. So that's like one of the, I think, things you generally sort of we keep at the end, but sometimes we forget. But I think that's one of the most important things as well. So I think, yeah, those are the sort of learnings, and I'll also give some of the key wins for the project, which has sort of we had for the client. Now the new solution actually can process, and this is what we tested in peak, is it can process about 1 million of consolidated events in 2 minutes, right? Whereas if I compare to the old solution, which almost took 1 hour, right, under the similar backlog. So from 1 hour to like 2 minutes of time, and 2 minutes I have put around because sometimes it's like 1.1, 1.2, is like a massive gain for the customer. Like they were really happy to see the solution scaling so well in terms of like processing volumes and deployment of things like that. That like it sort of really puts sets up a different benchmark. The second is like a system automatically scales ups and downs, which means earlier I think the old solution what they had to do was if there was a peak, they had to do an activity every time, which is like I want to add new nodes, remove new nodes, and this was a manual thing which goes away here. Like the system automatically scales up based on the backlog. If there are like let's say another 1,000 messages, spin up a new node, another 1,000 messages, you spin up another node, and that's you can define those things. The third is also it improved the data latency from 2 minutes to almost like 0 to 3 seconds. So earlier I think in some cases the data latency was 2 minutes. It has got better with like 0 to 3 seconds, and that's also another. It's basically really fast now. And then the last is basically the elimination of the database performance and tuning and cleanup related activity, because that also was an activity which they need to do on an annual basis. Now they don't need to do that anymore. It's automated. It automatically is, first you don't have a database which is doing this transactional requirement. Second, we have modified that with the Redis, which has an auto TTL. It sets up, it has a job, it sort of removes all the stuff. So that was like a really key win for the client, where they were sort of really happy with the solution which we have put together. Yeah, I think that's basically what I had, and I'll probably open up for a Q&A session where I will take your questions if you have any, and yeah, we'll go for that. Yeah, you have time, right? Cool. All right. Any questions or anything? Yep. Yep.
Was it something that you built already existing that you were able to use, or did you have to roll it in?
So I think you're talking about the configuration about the machines which you are talking about. Yeah. Okay. I think we have to come up with our own, and this is like sort of our idea how to do it, because this whole thing didn't exist. It was written in code. So like the whole thing was written in Kotlin in the project, right? And which means they had hard coded the name of the machine, what kind of events are required or not required, and that's basically like in the code. So we sort of just read it and thought it's a configuration. It should not be part of the code, and we extracted it out and said, this can be a simple input, right, which can be coming from and somebody can define that. So yeah, we came up with that idea, like sort of to simplify that logic. Yeah. Any other questions? All right. I'll hand over to Eva, I think, and then talk about some of the things on Fabric. Yeah, you could use this.
Thank you, Abhishek. So, hey everyone, this is Eva from Fabric TA team. And before we wrap up, I just wanted to share with you that we are currently hiring a few roles across different locations. So if you or you know someone are exploring some new opportunities, like a full stack technical lead, delivery lead, experienced designer, or automation quality engineering, you can just scan the QR code to get more details about the responsibilities and the benefits and the locations. And I'm also pleased to introduce our team member, Anna, who is wearing the white t-shirt over there. So she's focusing on the hiring for onshore team in Melbourne. So you can just grab her for a chat after the session to get more details about the opportunities. And if you know someone who is based in India or Manila or China and who are looking for this kind of relevant roles, just grab a chat with me as well. And I'm also happy to share with you more details about the opportunities. So, okay, so thanks for everyone joining this session and hope you can just have more aspirations today. Thank you.
Let's give another round of applause to Abhishek for sharing his wisdom with us. Is this your device?
Slide?
Yeah. And now it is time for our community marketplace. So as I said at the beginning, this is an opportunity for anyone who is looking for a new role. You know, perhaps you just finished studies and you're like, hey, I've just finished uni, looking for opportunities, or maybe you're someone that is looking to hire, or as I said, perhaps you've got a little project that you're working on and you're looking for people to join you. Or even sometimes we've had people come up to here being like, hey, I'm new to Melbourne, you know, keen to meet people. Or conversely, every now and then I'll put my hand up and say, hey, I'm looking at this technology, I don't understand it, I need to talk to somebody. So if you want to participate, just stick your hand up, stand up, introduce yourself, and you know, have your say. So with that, any volunteers? Going once. At the back there, it was Adam, yeah? Yeah.
I'm Adam. I'm new to Melbourne. Moved here from the States, and I have experience in AI and different systems, compilers, backend, cloud infrastructure, and looking for a new user.
Awesome. All right. Thank you, Adam. And welcome to Melbourne. This weather is about as good as it gets, just so you're warned. Anyone else? Going once. Going twice. Going 3 times. Alrighty. Well, if you perhaps thought of something afterwards, there is the meetup page where you can post on there being like, hey, this is me, this is what I want to talk about. Otherwise, we have, that was a community marketplace, and our next meetup is in March. It's last Thursday of March, is that what we're targeting? Yeah, you know, we're kind of bumping up into that weird time of year where it's Easter and suddenly everyone goes to sleep again, and then, you know, kind of, and also, you know, I don't know if any of you have been experiencing this, but it kind of feels like between January and Easter, like people aren't really keen to pull the trigger on anything, and then Easter comes and they go, oh shit, we better do that thing. So yeah, you know, it might feel a little quiet now, but don't get used to it. So in that case, thank you for coming. Thank you to Fabric for hosting us. They do keep an eye for the opportunities they posted up there. And as I said at the very beginning, we do have our topic survey, so please scan the QR code, let us know what topics you're interested in, and we'll hopefully see you at the next one in March. Thank you.